If you'll recall, in Unit 6 we talked about complex numbers, which have to do with imaginary numbers. So the imaginary number I is defined as the square root of -1. And for any positive number a, the square root of -a is the same thing as I times the square root of a. So if I wanted to take the square root of -7, well, the square root of -7 doesn't have a square root. Positive 7 doesn't even have a square root. So I could write this as I square root of 7. Well, the square root of -25, I can actually take out the square root of 25. It's 5, so this becomes 5i. So when I'm writing these out, I have two parts. A complex number consists of two parts. It consists of a real number, and then it consists of an imaginary number. Imaginary number is always with I. So if 2 is the real number, then 3i is the imaginary number. -4 would be the real number, and negative square root of 2i would be the imaginary part. For the third one, I don't have a real number, so I'm just going to put 0. My imaginary number would be 7i. And for the fourth one, I only have a real number. I don't have an imaginary part, so I'm going to put 0i with that. So we've already learned how to add and subtract with imaginary numbers. We treat them as if they're like x's, so I can combine my 4 and my plus 1, which would be 5. I could also combine my 3i minus 1i, which would be plus 2i. So my answer would be 5 plus 2i. I can also subtract. Now remember, there is a -1 in front of this, so I need to distribute that. 1 times 2 is -2. -1 times -2 is positive 2i. I can combine my 7 and my minus 2, which is 5. I can also combine my minus 3i plus 2i, which is -1i. I can also distribute when I have these, and I would do 3 times 2, which would be 6, and 3 times 5i, which would be 15i. I can also multiply utilizing the FOIL method or the box method. So 3 plus 2i times 2 minus 3i. 3 times 2 is 6. 2i times 2 is 4i. Negative 3i times 3 is -9i. Negative 3i times positive 2i is -6i squared. If you'll recall, I squared is really just -1. So I actually have 6 plus 4i minus 9i, and -6 times -1 is positive 6. I can combine my 6's together to get 12, and I can combine my plus 4i minus 9i together to get -5i. I can also divide 6 plus 15i by 3. All I have to do is divide 6 by 3 and I get 2. 15i divided by 3 and I get 5i. Lastly, I can divide 1 minus 7i by 6 minus 2i, and I can do this by multiplying by the conjugate of the denominator, which would be 6 plus 2i. Now, this is a lot of work, so I want you to look at your calculators, your TI-84s, and if you look right above the decimal point, you should notice that it looks like this. You have the decimal point, then you have I, that is blue, and then you have something else over here that's in green. This I that is in blue right here is the same I that you see here. So you can actually type this in your calculator. But in order to type this in your calculator, you must use your fancy fraction, so you must use alpha y equals n1. And you must actually type this in the way that you see it here. And when you do that, you are going to get 20 minus 40i divided by 40. Well, that's what you get if you did it by hand at least. You can divide 20, 40, and 40 all by 20, and your answer actually becomes 1 minus 2i over 2. And this is what you should get in your calculator. Since I'm allowing you to do these in your calculator, I'm going to let you do them all in your calculator, all 10 of them. They must all be done when you turn this in. And if you need help, you can come ask me how to plug them in the calculator.